Alright, I've got another quickie job to do here. So it's a primary I sold to a customer. 2-year-old primary. This is a 7172 FX kickstart only primary. They are solid. No electric start provision at all. So, the separate 4 covers a casting number in here. So this has no casting date on it at all, so it's the early one. Plus it has the solid holes, that's a good obvious sign there. So this one here had all the block off plates, everything on it. When I took the block off plate off, the whole bottom piece fell off, so I had to weld it up. So that's where we're at right now. I welded this all up, so now I'm going to go ahead and machine this flat. Make sure the primary cover is good and flat too. Crap over there. So, appears to be pretty flat on my table here. I have not filed the surface yet, but you can tell it's pretty even. Not rocking too bad. There's a little bit of a gap right there, I guess, right in the middle. So I have not filed it yet. That'll be next. Looks like filing things to make sure they're good and flat when I'm working on something. All right. I'm going to grab a nice dull file that doesn't have much cutting ability. Less chance of doing damage. I marked my files so I know which way they warp. So this one's warped like this. If you put it like this, where it warps this way, when you file it, it files on the 2 high spots right here and makes it uneven. If you flip it over like that and it curves this way, it tries to cut in the center part where it's hard to cut, so we'll keep it a lot flatter. Files also get twisted when they're twisted a little bit, same thing. So you just want to mark them so you know where they're off. I've never seen a flat file yet. You hear the burrs over here I'm going across. Alright, keeps that surface flat. We'll get this surface, the side we're going to work on. You always get a high spot down here where they grind on the ground. The file change as you go across and the noise it makes. It gets more of a dull sound as flat. Never stay in one spot too long. You can dig in. Okay. It's a lot flatter now. Okay, so now you look at what you did. You can see all the high spots. The deflective area is high spot. See, that's a high spot. Low through here. There's a nick right there, you can see it. Little small nicks all through here, high spot again, a bunch of little nicks. You go across your whole surface, you can see any imperfections, the big nicks right through there. This is all pretty flat, some nicks down there. Always that lip right there. That's where it drags on the ground, and then all along the surface. So you pretty well see what is flat and not flat. When you run your file across, you can hear it anyway. And feel it. You can definitely feel it. Now, if you had a sharp file, you'd be cutting a lot of that metal off you don't want to be cutting off. See, now it's a lot flatter. You have all those high spots anymore. So we had that gap through here before, we don't see it anymore. You go back and forth like this, trying to make it wiggle. You can hear a little bit in there, it's not dead flat, but it's within 5 thou. Pretty good. You'd be hard pressed to find any spot that's more than that, I bet. So it's pretty flat cover. Alright, so I'm going to tighten this down, take a trim cut across here, and flatten the surface out, and we should be good to go. And always put a lot of extra meat down here so the chain has something to eat on, besides the important part. Okay, put that right over there. Yep, catch a hole. In there. Don't think that's going to line up for us. Yep, we just made it. Use a large surface area so you don't squeeze too hard in one spot. You can definitely bend this thing down 30 thou by torquing on it, which we do not want to do. I'll catch a spot over here also. Just enough pressure to hold it. No extra. And it will bow down quickly. Now, the problem we got right now is we're probably going to hit this. I'm trying to cut, which I don't want to do. Oh yeah, that'd be a problem. Out of the way. Just tie it right there. About that much pressure. Now we can cut across here without hitting the side of my cutter too hard, which I don't really want to do. Grease. All right. Crank it up in the high gear. about 0. Back off 100, 200. Yeah, should just clear. Hit that cutter over here. Make sure you got your clearance so you don't cut on it. And make sure we sweep all the way across the whole surface also, which we will. Pull back there, be more centered. Alright. You want the chips to go that way so they don't hit you. You need to go down here. Alright. Now, no power. We got power. RPM. Quite that fast with either. Good 50s. I cut with hard aluminum, so it cuts pretty hard. It makes it nice and strong also. So you can see how nice and shiny that is. That's it's hard aluminum. So when your chain starts eating on it, it wears hard. If you use a soft rod, it cuts a lot easier. So 40, 43 is your soft. This is 53, 57, whatever the number is. 53, 56, something like that. So anyway, this is the hard stuff. So it works a lot better. So that was a 50 pass, which sounded like a pretty decent cut. Another 50. All the chips are going that way, so I'm not getting hit. Because they come off there hot. Okay, I'll do another 50. Pretty heavy chip load. Chip load is how thick of a cut you're doing. So that's how thick the material is. See, that's pretty thick. It's about 10-15 thou thick. So every time that cutter comes around, it's taking a 15 thou slop off the height of the material you're cutting. So we're cutting a 50 thou height and about 10-15 in. You have to go measure it to see how much it really is, but that's why it's clunking real hard. With a lighter cut, it doesn't make that much noise. But it's called removing metal fast. Okay, this one we're going to leave an extra 10 on here at the end. I already hit something. We're hitting on something already, so I backed off. backside right now. Okay, so we were just hitting right there. I came down until I just started hitting that. So we're a little bit lower here than over here. It's about 10 thou difference. Now how much is that from this clamp being pulled on it? Hopefully not much, because I didn't have that much pressure on it. But come back and check your pressures. See how that came up a little bit there? Back it off a little bit. Make sure it is against the table, because this side here is trying to lift right now. And make sure I'm all the way on the table. Where's my little shim stock at? Okay, this is a 1.5 thou shim. That goes through in places. Not over here, it is over here. So that's how much our cover is pulling in on us a little bit. So we are on this side. It's going under there a little bit there. So. A little bit more pressure than that, but not a lot. That's quite a bit of pressure, actually. You hear it's not against the table right there. It is there, but not there. So that's how much your cover's warped. See, it is tight over here. So when all this got welded, it pulled it up a little bit on this corner. Oop, just lost my tool. Shim stock. Yeah, so just pull it up a little bit. Welding will do that. Alright, so I backed that off. I'm going to take a light pass now. We're going to turn our cut speed way down here a little bit. On. Put that up a little higher. Let's see what we get. I don't think it'll clean all the way across, but we'll see. I didn't even see it even cut over there. It didn't. Okay, I'm going to go ahead and give it a couple more thou. We'll give it 3 thou. See what we get now. Now we're cutting. Yep. See the cut line there? Hopefully it'll go all the way across, but I got it. Nope, it's already fogged out. That's not cutting right there. Backed off and had a little bit too. Okay, give another 3 or 4 more there. See what it does. we're lucky to go all the way across, but I don't think so. Got one piece of porosity there. And crappy welder. Okay, we're still cleaning up. We just fogged out. Not cutting the rest of the way though. Alright. Go down until we hit. Right there we just touched. A little deeper, a little deeper. Getting close right there. So that was another 3 more pass. There's another 3 more pass. I don't know if that's quite enough yet. Nope. Close, but not yet. Two more. Right next where you weld always makes it low. Cleaning now. Yep. 100% clean. Some chips now because we're in the wrong direction. 5 thou thickness that we're cutting right now. We got that one little porosity hole there, which is right on the edge of where the original gasket surface is. Probably not even on the surface. Trail cut determines how flat you actually are. See how we're not really cutting on the backside, we're dragging to make a mark, but that means my milling machine is very, very square. So you're looking at that mark right on the backside, that cross-sex mark. It's your telltale sign of how good you are on your machine. Pretty good. I think it's pretty damn flat, what that means. Alright, we're past the edge now. Don't get near your cutter until it's dead stop. It'll still cut the piss out of you. It'll cut a finger off at that lower RPM. So you can see the crosshatch pattern in there. So that little porosity right there is all we got left. But the original depth of material is way under here. I added a bunch in here. So I'll come back and cut a little bit of that out, I think. Alright, looks pretty good. I'm happy with that. Looks like a lot of extra material I put under there. I'm going to leave that. I'm going to come back and grind half of this off right here. Clean it all up. Dowel's good, threads are good, that's all good. Looks like we cut about 12 thou out of that maybe to make it dead flat. So I don't know how flat it was from Harley, but it's flat now. We got very low pressure here, so that's the key. Keep the pressure down, it stays flat. Alright, that's how you fix one of these. Good to go.